This video is sponsored by GotchiFix. Thanks, GotchiFix. You never heard of them before? Well, let's fix this. GotchiFix is one of these new producers of measurement equipment, and they contacted me and told me, hey, do you want to review one of our multimeters? And I said, well, of course, as long as I can have my honest opinion about what I see, what I find, and maybe talk to you guys about some pet peeves somewhere around. So they sent me over this little gem. This is an LG303 from GotchiFix, and as you can see, it has a oscilloscope, it has a multimeter, and it has a function generator in there. So this is a complete lab bench measurement thing in one piece. Let's find out. So the first thing I realize, this comes over as a non-nonsense measurement tool. No flashy thingies on here, and it even has this nice packaging over here. Oh, there's some data on the back side. Let's have a look. Well, there are some typos here. The rang over them probably means range, and AC current is probably AC current. Maybe you want to check the typos over here. But let's go for the technical details here. So it's a 1000 volt DC thing. I'm not sure if I want to go really 1000 volt with something like that. But technically it can measure up to 1000 volt DC and 750 watt AC. So this is fine for mains voltage. It has a 600 microamps range up to 10 amps range. This is nice, 600 microamps. I could use this to test really low current applications and battery powered things. Resistors, caps, frequencies, so the usual stuff there. Diode test, 3 volt open. Down there comes the interesting part for me, bandwidth AC/DC 12 megahertz. This is probably the oscilloscope part. This is the thing I'm mostly interested in because, well, you know, I'm doing a lot of stuff with microcontrollers, so my usual test equipment is an oscilloscope and a voltmeter, maybe something to test continuity. But this is my normal thing. And there's this function generator in there. I don't really have a application for a function generator, so we maybe have a look at this, but we won't really do a real-world test for that. Okay, let's find out what's inside. Yeah, I opened this before because I had to play around with this. So looking inside here, you get these. This is a multimeter. It comes with a user's manual. Yeah, every multimeter should have a user's manual. I normally think if you need a user's manual for a multimeter, well, there's something wrong with the multimeter because I should be able to use the thing without using the user's manual. But what's nice, they have this cheat sheet over here that this explains all the functions in a very compact way. So this is nice. If you want to have a closer look, you can pause the video right now. But go on with the multimeter itself. So, first impression. This thing is tiny. If I feel the other multimeters, this feels really, really tiny, and it feels really light, which is a good thing, I think. Yeah, on the back side, there's a stand, as you usually have them. The test leads are, well, not the expensive ones, but they will do, I think. Test leads are a thing where I don't normally say, this is a very personal taste. I normally have very pointy test leads, but I know people who prefer these. You normally would get some test leads for your purpose by yourself, and then it's fine to have cheap test leads in here. You remember that there's an oscilloscope in there, right? And if you have a look, there's no connection for a normal probe. And this is the thing here. The oscilloscope works on the test leads. So I don't expect a really, really clear waveform there because there's no shielding. You simply go plop, and this is how you measure your waveforms. So we find out how good this is. By the way, this explains why this is rated for 12 megahertz. I'd go for maybe 10 because these test leads won't do good on any higher frequency there. What I really like is a big chunky rotary switchy thing here because I hate it when you have too many buttons over there. This shows me exactly where I want to go. I have my voltage, I have my currents, I have everything on there. For me, this is how I think about doing some measurements there. And there's a nice feature over here because it has one off switch here And on the other side, it has another off switch. So it doesn't matter in which direction you turn the dial, it always switches off when you go to the extreme positions. Nice touch. All right, let's switch the thing on. Ah, of course I'm on the wrong side. And there we are. This is a 240 by 320, probably OLED screen, I think. And it's pretty sharp, and I really like this. And you can step up the brightness over here. Yeah, this is way better. Oh, you can step the brightness down, and I'll bring this up to full brightness now. This looks really nice. They doing a bold job there with choosing the font for the multimeter. First thing, I think this is a nice design, but maybe I want to be able to choose between these kinds of blocky zeros there and something that has a filled number in there. Nice idea. I can live with that. Maybe the font could be a bit optimized. F4 is range. Yeah, so now I'm 600 volts. Now I'm 6 volts, 60 volts, 600 again. Why again? And 1000, and then it starts at 600 again. Well, this shouldn't be there. I think it should start by 6 volts and then step up. How do I get back into auto? This way I get back into auto. There's an auto button over here, so this brings me back to auto. I assume that voltage, current, and all the stuff is working. We maybe do some real-life experiments a bit later, but I won't go into details with that. Let's find out how good the continuity works. The thing over here. Now I have resistance, and I probably want to select diode mode. Continuity. Continuity is the thing I normally use because all these crappy DuPont cables, when I use microcontrollers, always need to check if the continuity is there. So let's do the usual test. Got the feeling it's not as fast as Mr. Bleep, but you know, that does it. And there's this nice touch with the red thing over there. It shows me, oh, there's continuity. By the way, I realized this is colored here. You got a color LED over here. Nice touch. Does this change when I do the select thing? No, it doesn't. Okay. If I switch the mode, oh, it goes to purple. Okay. And this is probably red, something. Yeah, some red. I just looking at the camera here. So, oh yeah, and this changes colors with all the modes. I like this design, but it feels a bit random. Maybe there's a color scheme here that I don't recognize, that I don't understand. But this feels a bit random. Maybe if you use these for, say, showing some high voltage or something, that would be better. Probably this thing does over here. But right now, this feels like a bit like a added feature. They didn't really think about this. Maybe this is all software, so maybe you can switch this to something that has more use for that. I have to talk to the engineers, right? But I know what you're looking for. Where's the oscilloscope? Wait, let me check one thing first. How's this thing powered? There's no thing in there. So probably there's a LiPo in there. So yeah, there's a USB port. Let's have a look. Yeah, it's closed very good. Which is good, really. It is really good. Let me do this off camera. Yep, USB port. It's a USB-C port, a charging port. So there's a built-in power. So there's a built-in LiPo cell somewhere in there. Is this better than the normal 9-volt block battery? Well, normally I'd say you can change the 9-volt block if it runs out. But on the other hand, I normally don't have a 9-volt block laying around. So this is probably the better way. I prefer my gadgets nowadays with a charging port and a built-in battery. How long this will take, I haven't run this down, and I was playing around with about 2 hours, and you see over there the battery still says something about lots of %. So this keeps up pretty nice. One thing I'm curious about, how good will this hold up in, say, direct sunlight? This feels like a meter you want to put into your field kit, and you maybe want to use it outside. So I live in Gran Canaria, so we have loads and loads of sun over here. And This OLED display must keep up with the sun. Well, I grab my phone now and we'll go out up to the rooftop and let's have a look how good this is readable under direct sunlight. Well, it's actually cloudy today. Well, we'll find out now. So, welcome to the Canary Islands, and yeah, we're in end of March now, and yeah, this is actually a cloudy day. We had the first rain in the year yesterday evening, and yeah, just a little GotchiFix. And I can still read this. I think the camera has problems picking this up. For human eyes, this is still visible. And this is brutal because I'm in direct sunlight right now. And I think this works pretty well for an OLED display. You really can't get any brighter here. Yeah, and it's reflective, of course it is, yeah. So the OLED display is a mixed blessing in here because, of course, you need this for, say, the oscilloscope part. But direct sunlight, well, let's go over to the shades a bit. Yeah, this works better. So if you can find some shade, you probably can read this. While playing around on the rooftop, I realized that the multimeter is roughly the same size as my phone. So this is a Motorola Edge 30, and well, you see the dimension is pretty much the same. And when I look at the camera right now, it looks like the screen is probably the same brightness. Well, okay. One more thought about the screen brightness. If you are outside and you can't read your phone in a good way, this is probably the same with this display over here, because it's roughly the same brightness. But they're doing a good job here, and I think I really like this display anyways, because it has its peaks, and we're going to find them out now, because where's the function generator? Let's go! So there's a little button, the red one in the middle, that says something like an oscilloscope. Let's go, what happens then? If you simply press it, it changes the brightness. If I hold it down, there's nothing happening. Okay, I'll do this again. This must be in voltage. So the scope, the multimeter must be set to something like voltage, and then you simply hold down the little button over here, and you're down in the function generator function thing. So the design is a bit different. I guess this is a separate firmware, because maybe the whole oscilloscope part, function generator part, is maybe a separate CPU. I'm not sure with that. Maybe we'll find out later when I talk to the engineers. This looks pretty much straightforward. Wave, frequency, duty cycle, and what's the other thing? Voltage. Okay, let's try them. Yeah, here I can select between a square, a ramp, or a sine. Frequencies. Oh, I can only step in direct increment. Well, this would work for me. You see, 50 kilohertz is a max output, so this is fine for, say, maybe audio applications. You know me. I normally don't do the audio things, so you maybe want to see if this works for your kind of application you want to do with that. F3 does the duty cycle. Okay. Oh, and now I'm switching the duty cycle. And there's the voltage, 3 volt peak, down to, yeah, okay. So again, this will probably work fine for something audio related, I guess. Dutch Linux, if you're watching this, maybe if you have an opinion on that, maybe type it down in the comments. I would really appreciate your input there. Again, for me, frequency generator isn't my normal thing, so this is why I'm skipping out right here, and I want to go straight to the oscilloscope. So let's find out how we activate this. So I'm guessing I simply press the button again, and then it brings me back to normal voltage mode. So hold down. I'm there. Guessing auto. Hold down. Oh, you have to hold down auto. Okay, I'm wishing that I have something over here that tells me hold down auto to switch to oscilloscope mode. Would be my forte here. So, yeah. Designers, please make a little label that tells me hold down for oscilloscope. Please do. Okay, let's have a look at the screen. Okay, this looks like a pretty normal single channel oscilloscope thingy. We have the 4 buttons, time, volt, trigger, and AC, DC switch. In the top row, you can see, can I point to this? I can point to this. Oh, let's do this. In the top row, you can see what the settings are. So you see there's 200 volts at 10 milliseconds. This is a setting I can't use for anything. 200 volts, no way. I normally use 2 volts, so this would be not my normal settings. And looking at these buttons over here, I mean, who designed this? Come on. Dark blue on light blue. Why? You did this very good in the normal thing. Let me switch back to the normal thing. This isn't the normal thing. Now I have to hold down this. These are nice buttons. I totally like these. This is good readable thing here, but hold down this, hold down this. This is simply bad design. I would guess these are bitmaps somewhere stored in the memory of the controller. This should be easy to change, because readability, please, readability, and again, think about it when at the rooftops, this should be good readable, so change this. This is not good design, really not. I really love the rest, but this is not a good design. The oscilloscope is the thing I want to play around with most, so I prepared some circuits that we can have a go with that. Let's find out. Oh, perfect. I just went out for some lunch, and yeah, when I came back, of course, the auto off had kicked in, so the meter was switched off automatically after, I think, 15 minutes or something. And I want to try out if this starts back in oscilloscope mode, because this was the last mode I left it running in. So now I'm switching this off and on again, as you do in IT. Shift and turn on, blah, 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 blah. And it goes to voltage. Okay, it doesn't remember the last mode it was in. Maybe this is a pet peeve, but I would love if it switches back on to oscilloscope mode, or function generator mode, or voltage mode in this case. Oh, and let me find out if it keeps the settings. So as I said before, the 200 volts it's running right now won't do anything for me. So let's change the voltage. 200 volts, and now I go down. Down somewhat. Oh, there it goes. 20 volts, 10 volts, 5 volts. 2 volts sounds like something I would normally use, because I use 5 volts, maybe 3.3 volts. So this would be my normal thing. So let's go exit. And now I switch the thing off. Switch it back on again. Okay, it goes to voltage. We know this. Go to function gen. Go to scope. Scope, please. And crap, it went up to 200 volts again. So my friends over at GotchiFix, this is something you can change, because this is software. You probably have some STM CPU inside the machine, so there should be something like a emulated EEPROM in the flash. Simply get a big structure organized where all the latest settings are in, and do a lazy write into the EEPROM. And on a boot up, you simply go for, okay, what was it set last time? I think I have the same problem, or the same pet peeve, let's say, with the ohms range over here. Because this is now resistance, and then it's diode continuity. This could be saved to EEPROM too. So if I switch it back from voltage to, and it should stay in continuity, because if I switch ranges over here because I'm trying voltages and I need continuity, this is maybe something where you can make a good product, this is already a good product, into a great product. And this could be done by software. This is simply a software update. You maybe want to have a look at this. Okay, enough with the pet peeves. Let's get into some real world examples. Okay, let's start with something that really lives on my desk these days. This is a experiment for a thing I'm doing together with Richard from Learn Electronics Repair. We're doing this HDMI cable tester thing, and there are multiplexers on there, MCP 27013 something, so I2C 16 channel GPIOs. And on this little thing over here, do you see the Knight Rider thing going on upstairs? Or it could be Cylons from Battlestar Galactica, the old ones, not the crappy new ones. And this is controlled all by this little thing over here, and this is a ATtiny 412. So this little ATtiny 412 goes by as I2C over to the MCP thing that has 16 IOs. the MCP is addressable, so that gives you a total of 8 of these on one I2C bus, and this means you can have 128 IOs of these chips with 8 of them, and this can all be controlled by a little micro over here. So let's see how the waveform looks over there, right? And I can connect to these resistors down here because they are the I2C resistors. So let me fix this up and let's have a look at the waveforms. So I hooked up the little scope to one of the data lines. It could be SCL, could be SDA. I'm not sure right now, and I'm way too lazy to look in the data sheet. Let's find out if we can determine what they are. Okay, it's 200 volts, so we won't see anything because this runs on 5 volts. Go down here and let's see if we find... Oh yeah, the spike's coming in. And down to 2 volts. Yeah, this looks nice. It's 5 volt signal, so this will be our data line. So I2C is normally high, and you can see this, that the data goes low. So this is absolutely correct. Let's change the time base so we can see what's on these spikes over here. Of course, wrong direction. I always do this. Okay, it's losing trigger. Oh, there was something. Oh yeah, this looks like a data form. Maybe if I do a different trigger mode. Oh, yeah, perfect. Okay, took a moment, but it caught a data set here. This is now in single trigger, so we only have one trigger here, and this stores that waveform there. As I expected, the waveform isn't very clean. This is probably because of the test leads, and I'm not using the original test leads right now. I'm just using some crocodile clips over here. But as you can see, this is fast enough to see the trigger, and this is definitely the data line because the clock line would be a up and down, and this must be data here. Is this a good waveform? Is this a bad waveform? For me to determine there is a waveform, this works fine. This scope isn't meant to be a precision measurement system. This is more a thing, is there a signal, is there no signal? And for there's a signal, this works fine for me. I pretty much knew what I was expecting as a waveform for this one. But how it works when I do the auto thing. So there's a big, nice auto button. Let's see if this catches the waveform the same way. Okay, whatever it shows me there, it isn't what I'm expecting. Let me see what it selected there. It selected some like 500 millivolts at 200 nanoseconds. I have no idea why it did that. Let's try again auto. There's some relay clicking. No, it grabs the same thing. Okay, I2C isn't the easiest signal because I have a short burst of data with a long pause in between. So this is probably roll of the dice here. So because it catches this all the time. Okay. So the auto mode is a bit finicky. Let's measure something different. For a different project, I was playing around with these GPS modules. Yep, this is a GPS module. And if we look at the backside, you see the classic ceramic antenna over here. If you've never seen these before, they are really great. They put out something like an NEMA, I think is the name for the code. And this is plain ASCII. It simply does an ASCII stream and it tells you where it is. But one big upside of GPS is it doesn't only tell you where it is, it tells you the precise timing here. So if you need a circuit with timing in there, this is a good thing. So if you need a circuit that supplies perfect timing, this is actually a way to set a clock. If you look over here, this little amber LED shows me the RX. So this is data coming from the module here, and it's simply dropping the data over here. And you see it does this every second. Every second, because it's GPS, it does this every second. And say for an Arduino something, you simply go for, there's a library for that, and it simply decodes you everything and sets the clock of the machine. You have a perfect timing with that too. So, I don't have an Arduino connected, this is just power here over the USB analyzer. Let's see if we can figure out if there's data coming in. There should be something around 9,600 bouts, so something fairly easy to detect. Let's have a look how the data looks. Oh yeah, this looks like a big data spike. Perfect. This is exactly what I wanted to see. Let's see if we can fix this a bit in the middle, because this looks weird. So the trigger is now set to DC. This is fine. We are running the whole show on 3 volts, so 2 volts is fine as a output here. Let me see if I can fix the trigger a bit, just because it's grabbing. There's a level thing here. Let me go up a bit. Oh, no. Come on, I don't want to press this all the time. Give me a repeat function on this button. Okay. And get the mode to single. And now we see something. Right, this looks like... This looks like data. It does. Let's zoom in a bit. If I ever seen classic serial data, this is classic serial data. And one of my pet peeves would be, can we have a protocol analyzer for this, please? I know, this is all software, and you have to do some research in here to find out what's the protocol, but it would be so nice if this thing could decode what I'm seeing here. So give me the ASCII representation of this. Maybe for the future. Hello, engineers, this is something for you for the next version, maybe. Anyways, this works pretty well. You know, the little LED gave it away that there's data coming in, but this is a nice way to check when you don't have a serial monitor or something lying around. And yeah, this works pretty well. Let me try the auto function. I'm already not a huge fan of the auto function, but give it a second try. Let's see what happens. This should be easier. Okay, it selected some better voltage. It thinks AC is a better choice here, and the trigger is all over the place. Yeah, I think the auto function needs an upgrade. If you watch our bi-weekly live stream on the electronics channel, you maybe remember me having these things around. These are addressable LEDs, and these are teeny tiny ones. These are 1.5 millimeters by 1.5 millimeters, so really, really tiny. And we were playing around with these last time, and I thought, okay, this is a digital protocol, so let's find out if we can measure the protocol over here. This is a digital communication, but it's 800 kilohertz. So this is pretty fast. And let's find out if we can see something with that. And yes, this is working pretty good. This is a data burst that goes through all the LEDs. So these are 51 LEDs, I think. And this goes through every of these LEDs. And every LED takes about 24 bits. And it takes it out of the data stream, so the data stream gets shorter while it's moving through the LEDs. And if there's no data stream left, there are no LEDs left. This is the trick with it. WS2812 protocol. Really fancy stuff. Let's see if we can zoom in a bit. And we can zoom in. Again, this isn't the clearest signal. I guess there's lots of interference coming from the non-shielded test leads. But, you know, to see if there is a signal, this is fine. Again, if you want to have precise measurements, you don't just use a scope. This is something where you go for, do I see something? And this is normally what I need. So, yeah, this is nice. Let's do the auto function. Let's see if something gets out of there. Okay, it loves AC, and the auto trigger doesn't help here really. So if you know what you're measuring and you know what you're expecting, this is fine, but auto, well, not for complicated signals, sadly. So, conclusion time. Besides some shortcomings, I really, really like this little one. This will probably be the multimeter that lives on my desk from now on. I already talked to the guys at GotchiFix about some of the quirks I found, and they said, okay, we'll have a look into that, and maybe there's a firmware update coming up. If there is, I'll let you guys know. And of course, I'm sure some of the pet peeves I thought about won't affect you in any way. The biggest plus for me is that it keeps me from searching for my oscilloscope, because most of the time this will do anything I need. The easiest way to get your LG303 is from Amazon. I put a link down into the description that leads you directly to this page over here. One of the biggest questions I think you guys have is, will this replace a signal generator, an oscilloscope, and a multimeter? For me, this would be in, say, 80% of my use cases. I said in the video that the oscilloscope in here is more a thing where you can check a waveform, not really measure it. And for me, this is an important difference. I normally simply check if there is a signal. If I want to have an analysis of this, I use a logic analyzer or a microcontroller who tells me what's going on that. And if I need something faster than the 12 megahertz over here, I probably use a real oscilloscope, a big oscilloscope, you know what I mean. But again, for 80% of my use cases, this will be enough. So for a beginner, I'd say, yeah, you can use this. If you don't want to spend 200 euros on an oscilloscope alone and $50 on a good multimeter, this is a good compromise. So should you get one? I know with about 90 bucks, this isn't really cheap. But if you use whoosh, this code on your order, that brings you down to, say, 67 something dollars. So I think this is worth the money. And again, I wasn't paid to say this. The lovely people from GotchiFix just sent me over this review unit, so I can tell you about this. No money to change hands. So this was a bit of a different kind of video. Let me know in the comments if you're okay with review videos. And also let me know if you bought one of those. So I see you guys soon in another video. Bye for now.